Swayam Prabha. Digital India. Educated India.
A very good morning, good afternoon, good evening to all my students and friends who are taking this course. I am Raghunandan Sengupta from IIT department, IIT Kanpur. So, as we were discussing in the last class, which was the 18th lecture, we just completed the concept of utility. So, there was quite a lot we have covered in utility analysis concept wise. And I did mention twice during the course of the 18th lecture that we will cover the problems of, say for example, in details using very simple numerical values for certainty equivalent concept, how you find out the expected value of the project, how you rank them according to the expected value, how you rank them according to the variance if expected value is not that important for you, or rank them according to the ratio of expected value to the variance or the risk, or the reverse ratio, that means risk to the expected value. Then we considered the concept of safety first principle, the three concepts of trying to minimize the probability, maximize the values depending on constraints of probability being alpha. Alpha is basically a general variable value which I am using. And then we considered that what is the concept of geometric mean values and how it has some semblance or concept with the other efficient frontiers, considering log of the prices is true or log utility function is true. Then we saw that how utility function being quadratic, it has some set of relevance to normal distribution of returns and all this. We will come back to these problems later on. So, in between either the 21st or the 22nd lecture, I will just take a break and then do that, even though it would definitely make a sense to do these problems in such a way that you will understand the concept of utility with respect to the concept of project management as such. So, let us start this 19th session or 19th lecture of half an hour, considering the extra other concepts which we will be covering for project management. So, the next topic of discussion is work break structure in project management. So, work break structure or WBS is basically a concept where you break up the whole project into activities and jobs such that they have some concept of how jobs flow from one to other, how the activities are linked, and how one activity or one job with delays, no delays, with slacks, no slacks, what are these? I will come to that concept of delays, slacks later on, how they are linked in order to accomplish the whole project which is at hand. So, WBS lays out the individual building blocks that will construct the project. So, if it is a software project, obviously there would be concept that how you do the software project management work, considering the collection of data is there for the project, trying to build up the data management system, trying to build up the flow process diagram of the programming concept, whether you need the pseudocode to be written down explicitly, whether you won't need to write the programs at different ends, try to combine them. So, all these things would basically come into the picture. The second bullet point is that in WBS, which is work breakdown structure, this process is critical because for most of us planning a project can be an intimidating task, and we can find out how the overall work or the project looks like by going through the components of WBS. WBS helps us create a necessary structure to the project by outlining the individual steps and how the individual steps are combined to give you the bigger picture of the project. So, what are the schematic or the flow process or the steps which we take for WBS, or trying to basically draw the project management curve or the graph or the diagram. So, curve, diagram, graph, they would all make sense as we start to do the problems later on. Stage 1 gives a detailed list of work which are primary of importance and which should be accomplished in some sequence. Stage 2 breaks down all the primary work in the secondary and what are the linkages between the secondary work inside the primary one, and if the primaries are related to each other or secondaries are related to each other. Stage 3 breaks down all the secondary work into its tertiary one and also tries to find out whether after the tertiary we have the first level below tertiary, second level below tertiary, and go on accordingly. And obviously, linkages between the first level of tertiary, the linkages between the second level of the tertiary, linkages of later layers are basically combined in such a way that they make sense, that how the overall project is managed and combined. So, consider this schematic diagram according to the WBS concept. So, you have you are planning a wedding. So, wedding can also be a project, you want to basically plan the wedding. So, wedding reception has to be planned and that is the project, and what are the deliverables? Deliverables may be you want to have a music function for that, you want to have the decorations, the food, the catering, the coming of the bride and the bridegroom, or say for example all relatives who are coming. So, they can be basically sub part of the overall project you want to basically manage. Now, in the under decoration can be you want to basically set up the stage, even though it is not given or drawn in the diagram. In the music can be you want to set up a stage, you want to basically call either the Senai or you want to basically have a DJ, whatever it is, basically you planned it accordingly. You give them a call, you basically set up the lightings. So, that can be sub part of the music deliverables as such. Decorations are as mentioned. So, these numbers which are given 1, 1.2, 1.3, 1.4 are just a numbering system in order to make you understand. So, 1.1 would be somewhere on the left where I am showing, it is not shown. So, you will have 1.5, 1.6, so on and so forth on to the right. So, under decorations it basically you decide the colors, what type of different cloths you should be used, you make purchase the flowers, you want to purchase the, say for example, the different type of linens which you want to basically lay on the table, the mats and different types of cutlery sets which you are going to use, considering that is a part of the decorations. Then you have to purchase the flowers, purchase the different type of things which are used for the birthday for the marriage party. And then if you go into, say for example, the food catering, it may mean that what is the menu you want to basically plan, who are the different type of guests which are coming, whether you will have a starter, what is the main dish, where it will be basically planned, and all these things are done. So, if you see this set of blocks which are there, it would mean somewhere that the AHP problem which you have done, where the hierarchies were there and where you went from the bottommost part to the top part, trying to basically combine the scores in order to find out what is the critical index, and based on that you make your decision. This concept wise drawing the blocks is exactly the same like the AHP one or ANP one, which is an analytical network process, which we would not do in this course, but I just wanted to mention that. And if you remember, I did mention about ANP part in the initial stage. So, these hierarchies basically when combined together give you the overall output of the project, which is basically to plan the wedding reception. So, these are the first layers, which is the primary layers, then you have the secondary layers, then you have the tertiary layers. So, this 1.3 has been broken down into, for our convenience in this problem, as 1.3.1, 1.3.2, 1.3.3. Corresponding to that, for 1.4 you can have different sub layers also. A cost estimate is which is made for the forecasting for the total final costs for the executing of the project is basically analyzed. The main purpose for the cost estimate is provide a baseline based on which the reference of the cost for the whole project can be controlled and our decision can be made. So, we want to basically control such that the resources spending in the project is kept within the cost frame used for assessing the feasibility of the project, whether the project is feasible, whether it has positive returns, whether they have negative returns, whether the fixed costs are very high, whether the variable costs are very high. All this concept can be cleared once you make a decision about the overall cost structures, as based on that positive and negative outcomes what you are seeing, you can make a decision whether you should go ahead and basically invest in that project. Cost estimation involves two important aspects. One is basically the estimation is an approximate calculations only, it does not give you exact calculations, because in case say for example the risk free interest rate is changing, it can change depending on the government securities, or say for example the price of petroleum crude oil is changing, consider your product is heavily based on the price of petroleum, or consider labor cost is increasing, or consider some political situation is changing such that the overall cost is increasing, or consider environment cost are to be brought into the picture. So, as these change, they keep changing the overall project cost. So, they are just tentative results based on which you will proceed for the final stage of the project. The estimate contains uncertainty. So, these uncertainties have to be minimized or kept as plausible as possible, depending that you are able to estimate the variances of these errors as far as possible. So, because these are the white noises or the effects which are coming out from the external environment and affecting your overall project. There are in principles two types of estimating methods. One is the synthetic method. In this method we estimate the cost without breakdowns and only use the characteristics of the system. This means the synthetic methods may be used in the early phase for the basic ballpark estimate which you want to make. So, overall bullet point costs, and that the analytical methods find their applications in developing controlling estimates based on which you can work. Analytical methods, in these methods we estimate the resource consumptions, breaking the total system down to subsystems, tertiary systems and such sub levels of the resources, and what is the relationship of the resources and what are the cost structure for each resources and how they affect each other. So, consider this graph here. For the first time I am trying to bring the graph. If you remember, I did mention long time back in the initial classes that distributions are there in the project management phase, and I did mention about PERT and CPM. So, in one of these methods I will come to that very soon, we use the gamma distributions. I also think I had mentioned about the gamma distribution, the most pessimistic, most optimistic time and the average time, median time and this concept. So, the graph is basically gives you that picture in hand where the probabilities are there in the y axis, that is true, while in the x axis we basically give the cost rather than the time. So, cost and time, if you remember, the concept of project management was basically to minimize the or find out the optimum time where resource constraints were not there, but later on I also mentioned that in general we will be interested to minimize the cost as well as minimize the time, such that trying to basically find the best project as such that both the objectives are taken into consideration. Even though solving those may be difficult, but we will still try to attempt our level best to basically take those objectives into consideration. So, the graph shows that you have the base estimate of the costs. The median is given because median is, if you know, is the value below and above which the probability is divided into 50-50%. So, for the normal distribution, just I am mentioning, for the normal distribution the mean, median, mode are the same values, but for other distribution it may not be same. So, in this case you have the mean value, median value and the mean value, and the contingency allowances are given. So, the base estimate is basically the estimate based on which you are going to work, and if the median and the mean values are on to the right. So, you will basically have some allowances. So, if you exceed that allowances, it means that you are overshooting your cost. If you are below or at your level of allowances, it means you are following the overall plan of trying to implement that project, considering the cost structures have been taken into consideration using the concept of there is white noise has been taken into consideration, the prices of the products or different activities of different jobs, of different resources, of machines, of human beings, everything has been done in the proper perspective. So, in project management scheduling, what we do is that is the process of converting the project goals into an achievable methodology for their completion, such that the main completion is to attain the overall objective of the project. So, if you remember in just the simple example of WBS, what we considered is that their wedding was a project and there were different deliverables based on the sub criteria or the groups of the deliverables being combined. Your main objective was to hold the function for the marriage in the best possible way, such that you minimize the cost, do it in the shortest possible time, and all these things which are practically feasible for that project. Now, if you consider the ideas which we were discussing in the first few classes, it was basically the project objective had to basically dovetail in the organizational objective, and also the social objectives have to be taken into consideration. So, if you consider these, your project goals and what are the variables, you will basically have a look at the variables in such a way that you are able to meet the criteria of all these sub goals in the best possible way. So, in project management scheduling, it creates a timetable and the network logic, what is the relationship between the activities, sub activities, tertiary activities, and relates the project activities to each other in the coherent fashion. Scheduling is a critical part, because the goal of a project management is to complete a set of goals in a specified time, in the specified set of the activities, how they flow. So, say for example, if you are trying to build up a house, your first objective would be to build the base, then considering the base is built, then you go into the first floor, second floor, and considering that has been completed, then you build the electrical system, the switch system, and the corresponding things. But in case if you basically try to finish the work without looking into the sequence of events, obviously the work would be finished first and much before time, but your overall objective of the project may not be met. The most efficient way we are doing is that we are creating a project schedule. The most likely we are able to satisfy this key success criteria in the best possible manner, considering the overall objective of the project which is to be met by us. Typically, there are two ways to determine project activities. One is the deterministic one. So, if you remember, I did mention about the distribution being beta and all these consequences. So, they can be deterministic time frame and they can be probabilistic time frame or the stochastic time frame. In the deterministic time frame, we assume the concept of critical path method would be coming. We assume that sufficient knowledge is available to develop a reasonable accurate time estimate for project activities, hence average would be taken. And under the stochastic or the non-deterministic time concept, we assume that knowledge is insufficient such that we have to develop reasonable estimates based on which we will work, and this is under the purview of PERT, which is project evaluation review technique. And we will also see that under PERT we will use the concept of most optimist, most pessimist, and why they are used. There are three terms connected to scheduling that concept of how the projects are combined, activities are combined to get the project. One is basically the activity, and activities which are the set of work items requiring resources to be executed. The event, which is the point in time when the activity starts or finishes. So, one job can start, scheduling of the jobs are done in such a way, considering this grinding one. So, grinding would basically have some resources. So, consider grinding starts on the first day, ends on the fourth day. So, the first and the fourth would be the concept of event, activity would be the grinding and the resources being utilized. And the milestones are planned, which are observable events connected to getting your overall project done. So, consider that you are using the grinding machine, you will grind some materials or some jobs and basically use them as clamps and fixtures, such that the work for the overall project can be done. So, there are two ways to represent a schedule. One is the concept of Gantt chart, one is the network one. Gantt chart we will discuss in very brief, even though we will do problems for that, and another network we will go into details for the PERT, CPM, then the concept of JERT, QJERT and how they are utilized accordingly. So, this is a very simple example of a Gantt chart. If you see the first column on to the left where I am pointing, it has the activities and the time frame are basically shown in the blocks. So, the time frame can be either in weeks, it can be in minutes, it can be in years, it can be in months, whatever it is. For this, the year concept has been used. So, if I am basically trying to do the work of trying to build a very big project, it can be trying to do the engineering work which will take a lot of time for engineering and design, which takes about 1 year as shown by the black line, black horizontal bar. Then the fabrication part, if you are, it is basically building up a building or a bridge, again it will take a long time, but it may so happen that the work of the fabrication part would only start after the engineering work has started. Obviously, that is true, but it need not start at the end when the overall engineering work is finished, because considering there are 3 important parts of the overall project. Part 1, let me mention it as part 1, part 2, part 3. So, part 1, the moment the part 1 the overall design is finished, the work for the fabrication for part 1 we can start. So, that means the delay which you are having here is based on the fact, not a delay, I should not use the word delay, is basically the leeway we should give, considering once the design part is over, then only the fabrication part can start, is say for example given by time t1. I am using arbitrary notions in order to make you understand. And then the overall work considered, considering that this black horizontal line is there, it completes here. Now, this horizontal line is not black, but is white. It means that it is possible that you can delay the start of the fabrication part by this quantum. That means you can shift, which means this black line can be shifted such that the end of this point matches exactly this end on this point, depending on if there is some resource constraints in the overall working of the fabrication part. Consider machines do not arrive, consider if there is a resource constraint of some material, consider technicians are not available, consider welding person is not available. So, if those happens, you have to consider that they can be shifted in such a way that those slacks can be utilized in order to cushion such that the overall time of the project is not exceeded. Then you have the module fabrication. So, module fabrication also consider it starts just after few days. This due days is basically T2, which I am marking now. After the GBS fabrication starts, then you have the deck fabrication. So, again these white blocks, horizontal ones, are the shifting which can be done, the number of days, number of weeks, number of months shifting you can do. Then the deck fabrication starts exactly as per the norm when the GBS fabrication starts. So, there should not be any delay, which means the time difference between the start of this activity 2 and activity 4 should be 0, that should not be any delay, they start at the same time. Then you have mating, the overall the fabrication part, the hookup, the tow to the field and commissioning work which is done, considering whatever project which is there. So, these are shown in, say for example, blocks which are white, and the dotted one, horizontal one, is where you are. So, if you are standing at this point of time, say for example 1 year plus few days or few weeks, based on that you are trying to basically analyze which work has started and how they are progressing and when they finish. So, these the 5th, 6th, 7th, 8th work have not yet started, hence they are not blackened, in the sense they can be delayed, in the sense if this whole work, if you see this deck fabrication and mating work, the overall time difference between the ending and the starting is 0. It may so happen that if due to some circumstances, some resource constraints, this goes on to more on to the right, that means delay is there, then the overall project can be shifted. So, these Gantt charts gives you in a very simple sense that how the works are related to each other and what is the overall time frame taken for each activity for the project and how there are slacks which can be utilized in order to minimize any overshooting of the time process for the project as such. So, the main advantage of the Gantt chart is that it is easy to read and understand. It communicates well even to persons not familiar with schedules and who may not have very detailed technical ideas, but they would basically get the overall feel that how the activities are commissioned one after the other, considering that what are the sequence or events which takes place and which activity follows the other and what are the number of days gaps or whether there are no gaps between the activities. Originally, it did not show precedence relationship between the activities, but modern softwares can be utilized where it shows the precedence relationship and what are the jobs which will follow and what are the delays and what are the relationship between the number of days which are between jobs and activities. Precision diagrams on the other hand is a schematic display of the project sequencing activities and the logical relationship between them, such that the precision diagrams takes into consideration the overall concept of the project in much better sense than Gantt chart. So, creating a precedence diagram on a network is crucial for several reasons. So, what are the reasons? I will go one by one. Networks clearly illustrate the interdependence of all tasks or work packages to each other and to the overall project completion as such. Networks helps us identify those tasks that are dependent on one another or the activities. This information tells us which activities might be highly coordinated to ensure smooth coordination and end of the work. Networks allow us to determine when the project will be completed, and networks also help us with overall master scheduling of the organizational resources, because they show us times when personnel must be fully committed to finish the project work as required. So, consider this sequence of activities based on which I will try to give you an example and feel how the network can be structured. So, consider the first, second, third, fourth, fifth columns are there. The first column has the heading of initial planning, job and the identification, which are marked as A, B, C, D, E. The alternative way of trying to denote these jobs can be not A, B, C, D, but can be the start and the end number, like 1, 2 for A, or D can be 3, 4. So, how the numbering had been done, once we see the diagram we will understand. Job descriptions are given. Forecasting of the sales is for A, pricing of the sales, that means you are doing a marketing project for the overall work which you are planning. C can be preparing production schedule, D can be costing the production, and E is basically preparing the budget. And the departments under whom they fall is basically sales, production, accounting, treasury, and the number of days required for each activity without the interrelationship is given as 14 till the value of 10. So, before we start drawing the diagram, I will just give you the concept of activity on arc and activity on node concept. So, depending on the nomenclature of what we use, we have two different ways of depicting them. One is either using a node, which is the circular one. So, the activities are basically are given as the node and activities on the arc. So, if you go back to the last slide, I am not going back to the last slide, but if you refer back to the last slide, A was being denoted by 1, 2. So, if you are going on the concept of trying to denote the activity, considering that it was more based on a node, then A would be used as a circle, as a node. Now, if A was being denoted that on an arc one, then the letter A would not be used. Rather than A, that the sequence of for A as 1 and 2 would be used. So, 1 would come here when I am pointing my finger, and 2 would basically come here. So, either you use A for this circle for a node, or for the arc you use 1, 2 in order to denote that. Hence, we have activity on arc and activity on node concept for depicting the project. So, if I consider this the example, I will just take another 1 or 2 minutes. So, activity on arc and activity on node. So, you have basically for the AOA network. So, this 1 to 2 is given by A, 1 to 2, that means I discussed, and then if you see the sequence of the jobs which were marked as 1, 2, 2, 3 and so on and so forth. So, the overall of the project is basically once 1 and 2 is finished, then B and C starts, which is basically 2, 4 and 2, 3 respectively. When C is finished, then only D can start, but the sequence of events is such that D and C and D finish in such a way that B also ends. Then only after B and D ends you can start E. That means E can only start after B, C, D ends, because if B and D has to end, which technically means before B A has to end and before D C has to end. So, if you basically translate that on a node concept, see here I have basically drawn the node as a square, just there is no such hard and fast rule. So, they are basically given a. So, that this 1 2 is basically A, and the relationship if you see here, A leads to B and A leads to C, which is true. If you see here, A leads to B, A leads to C, and then after C you have D, which is, if you see this diagram, the C and D is basically this, and after B and D is done, which is this, then only you can start E. So, the overall concept of activity on arc and activity on node gives you the same picture, but trying to depict in a different way, such that in different examples it will may be convenient whether AOA is used or AON is used in order to depict all the activities which makes the overall project. So, with this I will end the 19th lecture, and we will be in a position to continue with the network concepts, solve one problem and then come back to the concept of the safety first principle and all these things, such that once we complete the safety first principle and all the small problems and then also solve few network problems, it will make sense that how we take that into consideration for different projects of different conceptual framework. Have a nice day. Thank you very much.